So we got our objectives there. I can use distribution with algebraic expressions. And yes, we do have this. I mean, I want to go around telling people I learned algebra because it's kind of a swear word in normal society. But around math circles, it's like, yes, we love you now. Otherwise, they probably don't, but that's kind of weird. So I know how to combine like terms, and then I can model algebraic expressions if necessary. And it will be necessary on the assignment, which means that it could be necessary on the exams. All right, as much as we love vocabulary, here is more. So terms is just, it's some kind of value in a math expression, but it's separated by addition or subtraction. And this is kind of goes back to what we learned in order of operations stuff. You can see things that are multiplied together, but if they are multiplied together, it's considered the same term. And the same is true if you see division. If you see division by values, then it's considered an individual term. And the nice thing about this, that we separate these by addition and subtraction, and again, going back to the order of operations, if we see many additions and subtractions with maybe multiplication or divisions in between, we can kind of do in between addition and subtraction with the other two operations, multiplication and division. And that may not make sense, but we've seen examples like that before. What the heck, I'll give you one. I'm not going to solve it, but I'm just going to give you an example of something like that we've seen. So if it said something like 5 times 2, that's times 2, minus 4 divided by 4, plus 8 times 10, something like this. What you can do, even though it's not, it doesn't show us, you could do this term, which would be 5 times 2, it is an individual term by itself. But like we've seen in the past, and although we still work from left to right, you could do the 8 times 10 right now as well as the 4 divided by 4 right now. And then you can work with individual values to add and subtract after that. But they're considered terms. Like the 4 divided by 4 is a term. 8 times 10 is its own term. And if we can understand what a term is, then we can understand what a like term is, which we will need to know in order to simplify the expressions like we saw in the objective. So like terms is when we see terms like these in a math expression, but they are like each other. And yeah, that's a little redundant. But like terms, and this is kind of nerdy right here, but it may be the best way I know to say it. Terms in a math expression have the same variable. So we'd look up here, do they have the same variable? Well, they don't have a variable. So we'd say, well, these don't have variables. So yeah, these can be considered like terms, but you just have to simplify within. But they also have the same corresponding exponents. That's talking about the variables. So that means if you see a term like an x, and you see another term like an x to the power of 4, these, even though they are the same letter, cannot be combined because these are not like terms. So we got to be careful about those because students get this mixed up all the time. Not like terms. Okay, well that's not like terms. What would be an example of like terms? Well, if you had something like x and x. Okay, because now you have the same variable, they don't have any exponents, so we would consider these like terms. Or if you saw something, well, I'll use numbers as well. So if you had, let's say you had 4x, and then you had just this x right here, these would be considered like terms because they have x's. We don't care about this number that's attached to it unless it is an exponent. So if I were to go in here and I would just say this is x to the power of 2, and I was comparing it with a 4x, now these are not like terms. Now we want to keep it as like terms, so what do we have to do to make these like terms? You have to give the first x an exponent of 2. Now they are like terms, which could be combined. And in addition to that, sometimes you'll see that maybe that 4, maybe it's a negative 4 instead. Still like terms. I don't care about the number that's in front of the letter. I only care about the exponent if there is one, which there won't always be, but sometimes there is. Okay, it didn't talk about variables. I think we talked about this in 4.1, but a variable is just a letter. usually it can represent a number, just like we saw in the starter where we looked at formulas, right? And so formulas use variables all the time, but they're using letters for you to replace with numbers, whatever number you want, or whatever the situation says you should replace that letter as a number with. I hope I said that right. Terms and like terms. So, why are these like terms when why do we say this -4 doesn't matter? It's because this -4 tells us how many of these x squareds there are. Or in other words, -4 x squared would be the same as taking a negative x squared, but you'd need 4 of them. That'd be subtraction right there, by the way. So you'd have negative x squared minus x squared minus x squared minus x squared. I don't like writing it like this because I'm a math nerd, and so that's a lot of writing for me, even though I use technology to do it. But I can combine these and make -4x squareds. So this x squared right here, which I can write in addition to it, this x squared here, I could say, look, that's a positive x squared right there. And now, hopefully this is a more basic reason why I can take a -4x squared, which is this part of the expression, and combine it with this part of the expression. They're all x squareds, just some of them are negatives, some of them are positives. So since we do have some negatives and positives, now I can combine some of these as 0 pairs if I needed to, right? So for example, I could take these two, this negative x squared and this positive x squared. A negative and a positive, they're opposites, so they would be zeroed out in order to simplify it. So what's left over after you've zeroed out this one is that you'd have 3 of these negative x squareds right there. Now, this last word right here, coefficient, the coefficient is the number that's being multiplied by the letter, pretty much. So it says the base number of a term, that's fine. It takes the operation addition or subtraction as its sign. Yes, this part is important right here. But if I were to let's look at this one right here. We got this -4. I'll keep the colors. -4 x to the power of 2. So if we look at an example like this one, we say, what is the exponent? Now there's 2 numbers, but one is a base that's being multiplied by the variable, and the other one is an exponent of the variable. So it's the number that's being multiplied by the letter, which is not the 2. The 2 tells us how many x's are being multiplied together. This number right here, this -4, tells us how many of these are being multiplied together. Sorry, added together or subtracted. So the -4 is considered the coefficient in this case right here. But if I were to put something in front of it, so I'm going to make it it's not a like term. So that's 5 minus 4x squared. I can't combine those because they're not like terms. But where we were just talking about this being a -4x squared, it is now showing as 5 minus 4x squared, but the minus sign makes the 4 a negative. This kind of goes back to the terms. Addition and subtraction separate terms, but addition and subtraction are going to tell you if a term is negative. Like this term, it's negative. Now the 5, it's positive, right? So we wouldn't show it at the very front, but if I wanted to rewrite this, which I could do in it has the same exact value, but I'm going to rewrite the order here. So what I can do is I can take my -4x squared in the front, and then I can take the 5. Now that 5 is positive, so as a term by itself, I can't just write it by itself, otherwise it looks like it's being multiplied. I have to show the plus to indicate that it is positive. That's the hope. So if we were to look at these terms, let's look at this term right here, right? So if we were to look at that x squared, and I said, what's the coefficient of this x squared? That's going to be important to know. Because a lot of students look at this x squared right here, x to the power of 2, and they say, well, it's not showing an exponent, so it has to be 0. It's not 0. It's not 0. Because if it was 0, it would zero it out. Because anything times 0 is 0. It would be a 1. Compare thing, like we had this -1x squared and this 1x squared. Well, if you were to combine those two, they would zero out. I am going to be using this vocabulary quite a bit. I'll say term. Look at this term right here. These are like terms that we're going to combine. What is the coefficient right here? This kind of thing, right? Let's combine these coefficients because they're like terms, something like this. What is the coefficient of x? So right now they're saying, what is the coefficient of x? They may use different letters. They may say, what is the coefficient of w? What is the coefficient of y? I don't know. But here's the examples that we have. So we've got negative x. So we look at this one. And again, a lot of students say, hey, it's negative x right here. The coefficient is 0. Because again, it's not showing the coefficient. There is an exponent there. There is a coefficient. There it is. There is a coefficient there. You just can't see it. Yes, so it is negative 1 right there. So the coefficient on this one is negative 1. I'm circling. So we know what the coefficient is. Now again, the reason why we're doing these ones specifically is because it's not showing what the coefficient is specifically, but there is a value that's there. So let's go to the next one. The next one would read 8 minus x. So what's the coefficient on this one? So let's discuss the 8. So it's not 8. It's not 8 because a coefficient has to be multiplied by the letter. It's 8 minus the x, so it definitely cannot be the 8 right there. In fact, I'll kind of cross that out so we know it's not the 8. It's not the 8. Yep, this one also is negative 1 because it's negative 1 times an x. Now again, we're not seeing these right now, but they are there, and it may be helpful to see that they are there because when we start simplifying these, I think it's going to be fairly important for us. Now this last one is just showing, hey, here's a term. This is its own term. It can be one term. And by the way, this last one was 2 terms, an 8 and a negative 1x, or negative x. This is just an individual term. What is the coefficient though? Yeah, it's a 1. So if you see a letter, but it does not show a coefficient, it has to be a 1. These ones, since we cannot see them, I generally refer to these as phantom ones because they exist in reality. You just can't see them, right? They were always there. Like if you were to go back to this example down here, there's a 1 right there. You just can't see it. And sometimes that's problematic because we can't see it. But it was lurking in the shadows, always watching. And yeah, it also makes them kind of creepy. Okay, so let's look at a different example, and hopefully this will be a little obvious. But if I looked at 5x plus 10. Okay, so again, I'm asking, what is the coefficient of x? The 5 that's being multiplied by the x is the coefficient of x. Okay, well, let's try another one. Let's do negative 15 minus, well, you know what I'll do. Not to be a jerk, really, but just to make you think a little bit, we'll make a negative 3/5 x. So if you see something like this, the coefficient, part of the coefficient is the 3/5, but it's negative 3/5 instead. Because remember, that minus sign will become the actual sign of the term to its right. So if you look at a term and you need to know what the sign is, just look at the operation to the left, whether it's addition or subtraction. That will tell you if it is positive or negative. So even though the 15, it's negative, right? So we know that the 15 is a negative. Or like this 10 right here, we know it's positive because of the plus sign. If I were to go back here and change this into a minus sign instead, now it's a negative 10 term. But again, these last two that I did, this 2 terms right there, and there's 2 terms right there. Okay, combining like terms. Another way to say combining like terms, which is really what they're going to be saying on the assignment, is to simplify. So if you see that they say on the assignment, please simplify, they're really saying combine all the like terms that you can. So if terms are like terms, you can combine them, but the combination will occur with addition or subtraction because terms are separated by addition or subtraction. Now, they may not be very close to each other either, which kind of goes back to the commutative property of addition. And students usually ask, well, it's saying subtraction. You can move stuff around with subtraction. Well, as long as you say that subtraction is actually addition of negatives, then you can. But that tends to be confusing. So we just need to understand if we see like terms, even though they may not be next to each other, we can still combine them. Combine them in order to simplify the expression. So again, you may have 3 like terms, but when you add and subtract them, you should end up with one individual term to represent all 3. I feel like there's a one term to rule them all quote in there, but I can't think of it. So terms do not have to be like terms to multiply. That's correct. For example, just something as simple as 2x. These are not like terms. I can multiply these, even though 2 is a coefficient and x is a variable. But if I wanted to, and I said, you know what, I'm going to multiply this by 4, yeah, I can do this. It'd be 4 groups of 2x's, and then it would end up being 8x's. Not that we care about that yet. But I can multiply anything together. I don't care what it looks like. I can multiply it together, and maybe the product is pretty ugly. I don't know. Well, I guess a lot of math is ugly, but you can multiply any values together, even if they don't look alike, even if they're fractions and decimals and fractions, or negative fraction, whatever. You can multiply stuff together. But they have to be like terms in order for us to add or subtract them together. But we have to look at least at the variables. If the variables match, we can combine them, as long as the exponents match, which again we shouldn't see. And the coefficients will tell us how many of there are to combine. Now, are there terms that don't have variables? Of course there is, which we've seen before, something like 5 plus 2. Okay, this is an expression with 2 terms, 5 and positive 2. And these are like terms, which means that we can combine them. 5 plus 2 is 7. Now, that may be oversimplified, but it hopefully emphasizes the idea. If you see numbers on their own, they're called constants. I don't generally call them constants. I just say, look at these numbers. I don't know, I may say constants, but once we see numbers by themselves, you can start combining them. So it says simplify. So remember, if it says simplify, it really means combine like terms. Combine like terms. So I've got to look at these terms. Now, just to get us started off here, I'll read it. 12w plus 10. I read that wrong already. Let me try again. 12w minus 10 minus 15w plus 8 minus 11x. So just right off the bat, how many terms are there? Right now there's 5 terms. But the question that you answered is how many different types of terms are there? Which is still good. Because if you can acknowledge that there's 3 different types of terms, that'll help you to understand what you can expect out of your answer. Okay, so right now, and again, I'm not really doing any work, so I'm going to push this to the side. Right now, there are five terms in the original problem. 5 terms, I'll say to start with. Okay. One of the terms is 12w. Another term is negative 10. Another term is negative 15w. Another term is positive 8. Another term is negative 11x. But, like you guys said, there are 3 different types of terms. So there are 3 different types of terms. My iPad wanted to put food, which makes me sad. But, so 3 different types of terms. Now, the reason why that's important is because this means that the answer should have 3 terms. 3 different terms, really. But that's the iPad. Okay. This is just planning. We haven't even done any work, right? But you guys noticed there are 3 different types of terms. But to start out, there's 5 terms, meaning in the end, it will be simplified. It's become smaller. We start with 5 terms, we end with 3 terms. Yeah, that's simplified, and that's good, which is what we want. So let's identify like terms, and I like to do this from left to right. I'll start with these 12w's, because it's the first one on the left. Now again, is negative 10 a like term with 12w? I can't use this negative 10 because it is not a like term with the w term. Negative 15w, well, that has a w. So I will be combining it. Now again, I'm showing my work with this v thing, which doesn't have a formal name. But what I do know is that I'm combining w. So I'm going to put the w in right now so I don't forget it. And what I notice is that we start with 12 w's, and it's a negative 15, but it's going to read as minus 15. So it's really become 12 minus 15. This will tell me how many w's I end up with in this expression. So 12 minus 15 would say, well, we're subtracting more than we start with. So I know that I'm going to have a negative amount of w's. I'm just putting the negative in right now. And then what we do, hopefully remember, we take the big number and subtract the small one. 5 minus 2 is 3 in the ones place value. 1 minus 1 is 0, just zeros out. So that 3 is now a negative 3 w's. That's one of my 3 final terms. It's my w term. Well, I'll combine the constants. How about that? The numbers by themselves. So there's a negative 10. Now, it's just the next one to the left, from left to right. And I can combine it with another number by itself, 8. So the work would show negative 10, and then the 8 is positive, so we would show plus 8. Notice I don't have any letters associated here, so I don't have to put it down here like I did with the W. So negative 10 plus 8, I'm adding opposites, and there's more negatives than positives, so I expect the answer to be a negative. Now when it finishes, it's going to read as a minus, but I know the term itself is going to be negative, which is why I'm changing the color here. All right, well, if that's the case, they're opposites, so you take the big number, 10, and subtract the small number, 8. 10 minus 8 is 2, and that's how many negatives I have by themselves. There's 2 negatives, so we just put it in as minus 2. This last term, now that's 2 of the 3 terms, right? There's only 1 term left, and there's only 1 different type of term left, and it's an x term. Well, there are no other x terms to combine that negative 11x with, so I just write it in as a negative 11x, boom, and that's it. So let's look again. We started with 5 terms. We knew that there were 3 different types of terms, so the answer should have 3 terms. 1 term, 2 terms, 3 terms. That's it. Now I'm going to point this out, which can open up a can of worms. Just be careful, okay? So some students are like, you know what? I really like to put that negative 2 in front, and then I like the negative 3w right there, and then I like the negative 11x. You know what? Some students will be like, I like it up in front too. Think about this, what I just did. I just copied and pasted these down below. Now, I changed the way that the expression looks. I definitely changed the way it looks. Did I change its overall value? I did not change the value. I can move these around as much as I want. Like, again, let's say you wanted, maybe you want the negative 3w in the front for some reason. You can. In the future, by the way, math nerds are going to be like, you got to put this in this order. Don't worry about that right now, though. But if you can understand that you can write these in different orders, then you can understand that the computer or the assignment will accept either one of these. So I'm going to put an or statement between there, just knowing that, yeah, I can move this over and this over and this over. You know what I'm saying? Just we can move them as much as we want. Why can we move these as much as we want when they're negatives or minus signs? It's because it's really plus a negative. We're just not showing the plus negative because it's a lot more work, and it would not be considered simplified. All right, so negative 5m plus 7k plus 5 minus 6k minus 4m. I think I read that right. 5 terms. But again, there are 3 different types of terms. So in the end, we should expect 3 different terms. And I'm going to start again. I just like to start to the left. Now, we notice this negative 5m is furthest to the left. The next like term, it's not the k term, it's not the constant or this other k term. It's way over here, this other m term. Now again, I can usually do it better than m. I like to put the m in right now, just so I know how many m's I'm going to have. And again, all I'm really doing now is deciding what the coefficient is. How many m's am I combining? Well, it says up here, you got negative 5 m's, and then you're going to subtract another 4 m's. So we're starting with the negative, we're subtracting, which means we're going to make it more negative. We take the two values, 5 and 4, and add them. That will tell us how negative it is. Negative 9m's. Okay, now the next term, going from left to right, is a k term, and there's another k term right there. So I'm going to put in a k so that I know I'm expecting some number of k's. It says that it's 7k's minus 6k's. That's just a 7 minus 6, which is 1. Now I'm putting the 1 in here. It's a positive 1, so I need to put this plus sign in between that k term and the m. Now I'm okay with 1k's. I consider this simplified for now. But just so you know, math nerds in the future, if you don't make this a phantom one, they might not give you full points. So, because it wouldn't be considered fully simplified. Now that's two terms, right? We got an m term and a k term. I'm going to keep the 1 there just because I like it. But the last term that I have is just this positive 5 right there, the constant. So I'm going to show it in as a plus 5. Again, this is the order that I have. You may not have the same order, which is okay. Again, if you wanted to write this as, I don't know if I can do it. If you wanted to make it 5 and then maybe got your plus 1k here and then minus your 9m's, I don't know. You can. Or if you wanted to make this a 9 plus the 5 plus the 1k, it doesn't matter. It's all the same. So again, I'm going to put an or statement here. Just know that you can move these around so long as the term remains a positive or a negative based on the plus or, well, the negative or minus sign. Okay, the distributive property. Distribution is multiplication. Now, you may have heard of the distributive property. It could be just as easily called the multiplication property, or multiplicative, I guess. It just means you're going to multiply stuff together. Now, students look at this and they're like, I don't see any multiplication right there. There is, you just can't see it. Remember, multiplication is the only operation that doesn't always have to be shown. So I'm going to show it, even though you don't have to. There's multiply right there, the dot. In fact, it shows up in two other places in this equation, here and here as well. We just don't usually show multiplication, especially with letters like this. Okay, this is distribution, but it's kind of an oversimplified version of distribution. It's possible that you've seen distribution like this. Now, what I'm showing here is what I'm multiplying the a by inside the parentheses, which is times the b. And that's how we get a times b right there. And I call these distributive rainbows. It's not technical or academic, but it works for me, okay? But that's a double rainbow, which has been known to make full-grown adults cry. And the next one, that's a times the c right there, which is shown right here, a times c. So we're just multiplying something on the outside of parentheses by stuff on the inside. And this is just showing two terms. It could have three terms in here, so you may have to have like a third distributive rainbow or even a fourth, I don't know. Today, I think we'll only see two. But if you see multiplication, and so we've already seen problems like this, right? So it's like a negative 7x, right? No need to distribute right there because this negative 7 is already being multiplied by the x. What we're talking about is if you see like a negative 7 times an x plus 14y or something like that. See, now I must use the distributive rainbows in order to simplify this so that, well, I guess we make the one term two terms, but it separates them. Students look at this and they're like, that's not distribution right there. Well, it's multiplication, so it is. So here's the problem, right? We see this. When we see distribution, generally it's over two different values. But you can distribute into one value. So we got 4 x's. And I'll write this out because maybe this will help us understand. But it's 7 groups. So this goes back to what we learned what multiplication is. 7 groups of 4 x's. 4 x's. Okay, well, 7 groups of 4 x's. If you were to combine those, I'm going to show the work like this. If I were to combine these, which I am, combine as in multiply, how many x's would this result in? Well, it would be 7 times 4 x's, and you can even show the x there, but 7 times 4 would be 28 x's. That's as far as you need to go on this. So that is one distribution. That was one distribution, one multiplication. Now we're going to look at this one, which has, in distribution, we got two distributions. Try this one out. I'll just let you know, I expect you to get this one wrong. There's something that students usually miss when we start this. So if you make a mistake, that's okay. Most people do. We'll learn from it. All right. Now, when you're simplifying expressions, there's two big mistakes that students tend to make, at least early on when we start to learn this. One of the big mistakes is where they say, look, 3 minus 9 right there, boom. And we can't do subtraction before multiplication. Yeah, but there's no multiplication. Oh, there is. You just can't see it. The multiplication is between the 9, that's not actually 9, it's negative 9, and the parentheses right there. So just like order of operations, we still have to do this multiplication before we do the subtraction or addition. So I'm going to distribute, and we should ask, what am I distributing? It's not 9, it's negative 9. So I've got to take this negative 9 and distribute or multiply it by the 5x's. So this is going to be negative 9 times 5x's. So again, how many x's would that be? Negative 9 times 5. It's a negative times a positive, so we know it's going to be a negative. 9 times 5 is 45. Sign and then the number. So just that part is going to give us negative 45x's. Now I will distribute the negative 9 to the 3. Negative 9 groups of 3. So negative times a positive will result in a negative. 9 times 3 is 27. Now we still have that 3 in the front. But generally speaking, when we start this stuff out, students will write this in as a positive 27. Yeah, so that happens quite often. Now I'm going to combine my like terms. Well, I got a 3 constant and a negative 27 constant. That'd be 3 minus 27. We're taking away more than we start with, so I'm expecting a negative. Take the big number and subtract the small number. 7 minus 3 is 4. Drop the 2. We end up with negative 24. And then the x's, there's no other x's to combine it with, so we're going to end up with negative 45 x's. So we got the two terms. We had 3 terms to start with. It was simplified into 2 terms, which is good. But again, if you wanted to, not that I think you'd want to, but you could write it, because some students like to write it in an order with an x in the front and then any constants second. Doesn't matter. It's the same thing. Just looking at this, because we're used to just kind of getting a final number at the end, students have a problem. They're like, what do I do after this? You don't do anything. It's done. That's it. It's simplified. It has an x term and a constant. You can't combine those. So leave them alone. So a problem like this one, it generally gets students because they're like, I don't know what I'm distributing right here. But it goes back to what we saw a few slides ago, where we saw that if you don't see a number, it has to be a phantom 1. Now again, this is not just a 1, it's actually a negative 1 because of the minus sign. So we're going to have to take that negative 1 and multiply it by both the 8x and the 2. So I'm going to start, that's going to be negative 1 times 8x's. So how many x's is that? Well, negative 1 times a positive. Negative times positive is going to be a negative. 1 times 8 is 8. So we get negative 8x's. And then the second part of the distribution, it's a negative 1 times 2. So a negative times a positive is a negative. 1 times 2 is 2. So now I have 7 minus 8x minus 2, 3 terms, but we're going to narrow it down into 2 terms because there's only 2 different types of terms. And that is the 7 minus 2 right there. Now those are constants, so I can't drop the x, but I can do 7 minus 2, which is 5. Now this 8x is not 8x, it's negative 8x, so I'm going to show it as minus. The minus is the negative sign for the 8x's, negative 8x. But again, if you wanted to rewrite this with the x term in front, you can. And then you'd put the 5 here behind it, but it's positive, so you have to show the plus sign there. They'll show right there, a common mistake, students will show negative 8x plus 2, but up here it's a negative times the positive, which makes it a negative. Okay, well, we definitely have this set of parentheses here. It's a better print, I don't know. Okay, the parentheses generally show multiplication. which means distribution, and distribution means multiplication. So we're going to start here. That's a negative 10 distributed or multiplied by negative 7x's. So negative 10 times negative 7x's. So how many x's will that be? Negative times a negative is a positive. I'm not going to show the sign, but 10 times 7 is 70. So we're starting with this positive 70x's, and then we'll distribute the negative 10 to a negative 5 as well. So negative 10 times negative 5, because it's distribution. That's two negatives, which will make a positive. So I'll show the sign now since it's plus. And then 10 times 5 is going to be 50. Now that's there's two fairly large numbers. But let's see what happens with the distribution of the 8. So again, here's another set of parentheses. I'm going to distribute the 8 into the parentheses into each term. Now that's positive 8 because of the plus sign. So that's going to start out with 8 times 3x's. How many x's is that going to be? 8 times 4 is 24. 24 is positive, so I will show the plus sign. Now I'll distribute the 8 to the negative 1, so that's 8 times negative 1. It's positive times a negative, which is a negative. 8 times 1 is 8, so negative 8 or minus 8. And then we have 8 groups of 4y. 8 times 4 y's. How many y's is this going to be? 8 times 4 is 32. And again, it's positive, so I'll show the plus sign. Well, let's start combining like terms. And right now we have 5 terms again, but there's 3 different types of terms. I'm going to start with the x terms. So I've got 70 x's and 24 x's, both positive, by the way. So I'm going to take the 70 and add the 24 x's. 0 plus 4 is 4. 7 plus 2 is 9. There's 94 x's. So that's my x's. Next up, I've got my constants of 50 and negative 8. So that would end up being 50 minus 8. So make that a 10. 10 minus 8 is 2, drop to 4. And that's going to end up being 42, but positive, so we'll show this with a plus sign. Finally, at the very end of here, we have the positive 32y's. It doesn't have any other y terms to combine it with. So we're just going to keep it as a positive 32y. Now I'll emphasize this once again, but the order here does not matter. As long as the signs, these 3 terms are all positives, as long as you keep all the terms positive still. Right here, and again, I guess the emphasis on this problem is the first distribution here with the negative 6 that needs to be distributed. It's negative because of the minus sign to its left. So it's really negative 6. First, we'll distribute to the negative 8x's. So that's negative 6 times negative 8x's. So how many x's is that? A negative times a negative is a positive, so I'll show the positive sign. 6 times 8 is 48. So we have 48 x's just from that. Now we've got negative 6 times negative 4. So again, 2 negatives make a positive. 6 times 4 is 24. Now here's another mistake. It's not so common, but what students will do sometimes is they may take the negative 5 minus 6 first to get negative 11, and then they'll distribute the negative 11. It's not as common, but it does happen, but it is an error because it's out of order. It's not within the order of operation. So you have to do the multiplication, which is distribution first. Next up, it's just 12, but it's positive because of the plus sign right there. So it's really going to start out as 12 times negative 3x's. So once again, how many x's is that? It's a positive times a negative, which will make a negative. 12 times 3 is 36, so negative 36 x's. Now we got 12 positive times 2. They're both positive, so the answer will be a positive. So plus 12 times 2 is 24. And yeah, we still got that negative 5 in the front. So this is our new expression with 5 terms. But there's only 2 different types of terms. Well, that's pretty good. So I've got my constants first. I've got negative 5 plus 24. And then we can even add this other 24. So let's do this 2 at a time. So I got negative 5. Okay, so plus 24 means that they're opposite signs, but the 24 is bigger. So the answer will be a positive just from that. And then we'll take the big number and subtract the small number. So 14 minus 5 is 9, and then we'll drop the 1. So that's 19. So we now have 19, but then we got the plus 24 as well at the far end to the right. I should have stacked that. So 19 plus 24. 9 plus 4 is 13. Carry the 1. 1 plus 1 is 2. Plus 2 is 4. So the constants combine to give us 43. Now I will combine the x's, 48 x's minus 36 x's. So how many x's is that? 48, and then it's minus 36. 8 minus 6 is 2. 4 minus 3 is 1. It's 12, but it's positive 12. Or, again, if you want to rewrite the order, the 12x would be positive, and then the 43 is positive as well, so show it as a plus sign. Either one of those works. So our other objective, right? We got to be able to model this stuff. So you're going to see it looking, well, kind of like this on the assignment. So you got the big squares right here. That's x to the power of 2, x squared. So it's an x. This would be, if it's red, it's negative. So yellow's positive, red is negative. If it's just regular x, then it's just a bar. I'll call that a bar. And then if you got ones, individual ones, then it would be, I don't know, a small square like this. But again, red is negative, yellow is positive. Opposites make zero pairs. It's true. And we've seen this before where it's happened with just regular numbers. So if you had something like -5 and +5 combined with addition, like this, they make a zero pair. So you'd say, well, that value is 0. And that can happen. But this happens with x's as well. So if you had like 4x's and then you said, well, minus 4x's. These are opposite terms, a positive 4x and a negative 4x. So you'd end up with just nothing in the end. Or if you wanted to be a little bit more specific, you'd say, I have no x's, 0 x's. That's fine too. But we have to be able to read these because I think it's gonna give us an expression in this modeling format, and then we have to say what the expression is. So the way that we have this, we got 2x squared minus 3x plus 4. These are all three not like terms. Now some students say, well, you got the x's though. Yeah, this one's an x squared and this one's just a regular x. We cannot combine those. So this would be considered fully simplified. We just got to show it with the tiles, right? So I know that a positive, this is positive 2, and we have to use yellow, and they're x squared. So I'm going to take this x squared right here, and I need 2 of them. 1, 2. Those 2 yellow squares represent 2x squareds. That's it. Now the negative 3x, so it's negative, so I'm expecting the red bar. Okay, and a regular x is just an individual red bar, but I need 3 of them. So there's 1, 2, and 3 of them. Now think about it like this. The 2x squareds, it's a different shape than the x shape, which is why we cannot combine these. I can't say that this red rectangle can zero out with this yellow square. And now the final part, there's a positive 4, so we're going to use these smaller ones, but I need 4 of them. And there's 1, 2, 3, 4. That's it. I just use algebra tiles to create that expression. It is done. So this one is r's, but at the bottom it says x's. I don't know why they put r's in there, but I assume that's the way it's going to be on the assignment. Once again, this is a negative 2r squareds, and that's the red one. So I got the red box, but again, that's a negative r squared, but I need 2 of them. So that's that. Now we got 4 positive r's. Now again, we're just going to use this as an x. There's 1 of them. I need 4, so 1, 2, 3, 4. And then finally, an individual negative 1. Well, that's the smaller one. The smaller red square. There it is. That's it. Below is a model of a polynomial, don't worry about that word, being multiplied by a constant term. So polynomial is just, I don't know why they're calling it polynomial, but I guess it has an x, whatever. But it's being multiplied by a constant term. Yes, it is. The expression would be something times something equals something else. And so we have to look at this in the context of the legend down here. Now, there's no squares. So even right now, even though I mean, it's part of the legend. I'm just going to cover that up so that we don't get stuff mixed up. And the bars now are laid flat instead of them being vertical like this. So what's being multiplied? Well, it's kind of like our multiplication table. So it's like this. This would be the product of this column and this row, kind of thing. So the product is in this part of the, I don't know, it's a quadrant right there. And so here I can just look and see that this area is the product. I'm getting there, product. Okay, why do we need to know the product? Because it's going to go in this blank right there. The factors are these two, and that's going to be these outside parts. So in other words, this part is one of the factors, and it doesn't matter which one it is. And then this one will be the other factor up here at the top. A factor, I said factors, but factor times a factor is a product, because factors are being multiplied together. Now again, it doesn't matter where you put them. I'll put the orange one here, and then I will put the red one, the green one rather, here. So we know it's multiplication because they kind of gave it away, but they also said it's being multiplied up here. So we were expecting factors, hopefully in the beginning. So I'll start with the orange, and the orange we've got, this would be an x, and this one also an x. Positive x's, because we see down here, that's my positive x. And so that's an x and an x. That would be 2 of the x's, which we then would multiply by the green, which is really these red squares, these red individual squares, they're ones. Those are going to be negatives, which is okay. How many are there? 1, 2, 3, 4, 5, 6. So it'd be 2 times negative 6. Now, you may be able to do that in your head even, or just do it on paper to figure out what the product would be, but I am going to use the model to find the product. So these are all x's because they're rectangles. There's an x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. So the result is 12 x's, but those are red, so your product is going to be a negative. Maybe I should have done that first. Either way, this is what you're going to fill in on this assignment. Try to make sure that we have all that vocabulary down, but hopefully that helps us with the objective as well, because yeah, combining like terms is simplification, or simplification is combining like terms, and then distribution, multiplying, then modeling, which we just barely saw.